Alright students, welcome back to this Athenian Stranger tutorial video where today I thought I would help you with some of the homework. This is homework 2. In the first problem we're asked to find the missing angle, and the thing that I've asked you to do in addition to simply finding the angle is indicating what theorem or postulate that you used to solve for the missing angle. So in this problem we're given a triangle, and we have two angles and we're missing the third angle. So we will use the triangle angle sum theorem, TAST. And what that triangle angle sum theorem tells us is that if we add up all the interior angles of a triangle, they have to add up to 180 degrees. So the benefit there is if we simply add 76 to 59 and subtract that sum from 180, we'll have the missing angle. So I'm trying to find a place to do that here. 76 and 59 add up to, see, this is 15, carry the 1. 7 plus 5 is 12 plus 1 is 13. So these add up to 135. And if we subtract 135 from 180, we will get the answer that we're looking for. So we have to borrow here. 5 from 10 is 5. 3 from 7 is 4. So by the triangle angle sum theorem, this missing angle is 45 degrees. Now on to number 2. Here we have an exterior angle, angle 1, and we have two interior angles. So what we're going to use here is the exterior angle theorem, EAT. And what that one tells us is that the exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. So let me show you what the adjacent angle is. This would be the adjacent angle, and these two angles, 62 and 67 degrees, are non-adjacent to angle 1. So what we do is just add these two together. 62 plus 67. So 2 plus 7 is 9, and 6 plus 6 is 12. So by the exterior angle theorem, the missing angle 1 is 129 degrees. That is the angle that we found just now. Okay, so we'll put here 129 degrees. Now in this problem number 3, we're presented with a unique situation. First, notice that we're given the exterior angle, 152, and one non-adjacent interior angle. So we can't apply the, we have to think about what the exterior angle theorem is telling us. Okay, the exterior angle theorem is telling us that this angle here is equal to the sum of these two. So what that means is 152 degrees is equal to this non-adjacent interior angle, 115 degrees, plus the unknown angle, 1, which we'll call x. So to find x, we just subtract 115 from both sides, and we'll have solved for the missing angle. Have to borrow from 5, turn it to 4, make 2 into a 12. 5 from 12 is 7. 1 from 4 is 3. So the missing angle by the exterior angle theorem is 37. Because 37 plus 115 is 152. And that's what the theorem tells us it would be. So this is 37 degrees. Okay, and number 4, right away I'm noticing that angle 2 is a vertical angle with angle 42, with the angle that is 42 degrees that's opposite. So angle 2 is 42 degrees. This is the vertical angle theorem. Angle 2 is 42 degrees. Angle 1 can be found using the triangle angle sum theorem. Angle 1 can be found using the triangle angle sum theorem, which states that if we add 50 plus 42 and we subtract that from 180, we'll find the other angle, because what the triangle angle sum theorem says is that all the interior angles of a triangle have to add to 180. So first let's add 50 and 42 together. That's 92. And we'll subtract 92 from 180. We have to borrow all the way over here. Make this 17 and this 10. 2 from 10 is 8. 9 from 17 is 8. So the missing angle is 88 degrees. So angle 1 is 88 degrees. Angle 2 is 42 degrees. And now we just have to find angle 3, which we can do using the triangle angle sum theorem, TAST. We're given two of the interior angles of a triangle, 25 and 42, and we just have to add them up, 25 degrees and 42 degrees. We have to add those up. 5 plus 2 is 7. 2 plus 4 is 6. And we subtract 67 from 180. We have to borrow from the 8, turn it to a 7. The 0 becomes a 10. 7 from 10 is 3. And 6 from 7 is 1. We bring down this 1. So the missing angle here at missing angle 3 is 113 degrees by the triangle angle sum theorem. In number 5, we have a combination of different triangles here. We can apply the exterior angle theorem to find angle 1. Now we can't apply that just yet because I noticed we're not given angle 2. But what we can do is apply the supplementary angles theorem here. 118 and angle 1, 118 degrees and angle 1 form a linear pair. They are adjacent to one another, and if we have to add these together, it has to equal 180. So angle 1 is just 180 minus 118. Okay, so angle 1 will be using the supplementary angle theorem. And if we take 118 from 180, let's see what we get. First, we have to borrow from the 8, turn it to a 7, make the 0 a 10. And now 8 from 10 is 2, and 1 from 7 is 6. So by the supplementary angle theorem, angle 1 is 62 degrees. Well, now that we know that, we can solve for angle 2. Angle 2, we can use the triangle angle sum theorem because we have these two angles inside this triangle, and all of these angles, angle 2, 62 degrees and 73 degrees, have to add to be 180 by the triangle angle sum theorem. So if I add 62 and 73, 2 plus 3 is 5, 6 plus 7 is 13. I get 135. So if I subtract 135 from 180, I will have the missing angle 2. So I have to borrow from the 8, turn it to a 7, make the 0 a 10. 5 from 10 is 5, 3 from 7 is 4. So this missing angle is 45 degrees. This is 45 degrees. So that's angle 2 is 45 degrees by the triangle angle sum theorem. Now we have to find angle 3. And there's a couple ways we can do this. I can see a couple different ways that we could accomplish our goal. I think the most direct way would be to imagine this as a larger triangle. Think about it like this. This triangle here as a whole. We have this angle, 62 degrees, and we have part of this angle, part of it's 45, and this angle is 49. Now they all have to add up to 180. So what I'm suggesting that we do is we add 45, 62, and 49, and we subtract that from 180, and that will give us missing angle 3. So we already did part of this, didn't we? Well, no, I guess we didn't. So we need to add 45 and 62 together. 45 and 62, and also angle 49 down here. All three of these angles have to be added together. 5 plus 2 is 7. 7 plus 9 is 16. Carry the 1. 4 plus 1 is 5. Plus 6 is 11. Plus 4 is 15. So these all add to 156. So angle 3 will be 180 minus 156 by the triangle angle sum theorem. Triangle angle sum theorem. So let's borrow from the 8, make it a 7, make the 0 a 10. 6 from 10 is 4. 5 from 7 is 2. So the missing angle is 24 degrees. Angle 3 is 24 degrees by the triangle angle sum theorem. Okay, and number 6, we have two parallel lines indicated by these symbols here. These little arrows indicate they're parallel lines. And I want to point out that we have two different transversals. Okay, remember, when we see a transversal, we're going to be thinking alternate interior angles. And here's that theorem if you need a refresher. If two parallel lines are cut by a transversal, then the alternate interior angles are equal. So let's identify the first transversal. There's two in the picture. Here's one right here. And what that means is we have to look for the Z shape. It can be a regular Z shape, or it can be a backward Z shape. In this case, we've got the regular Z shape. And what that tells us, remarkably, I always find this one remarkable, is that angle 3 must be equal to angle 47 by the alternate interior angles theorem. So angle 3 is 47 degrees. So angle 3 by the alternate interior angles theorem, angle 3 is equivalent to angle 47 because they sit in the corner spaces of that Z shape. So angle 3 is 47 degrees. It's a powerful tool, the alternate interior angles theorem. Now that we know that angle 3 is 47 degrees, we notice that angles 3 and 4 form a linear pair. They're adjacent to one another, which means they're supplementary and have to add up to 180. So we subtract 47 from 180 and we'll get angle 4. So let's do 180 minus 47. We have to borrow from the 8, make it a 7, make the 0 a 10. 7 from 10 is 3. 4 from 7 is also 3. And that 1 comes down. So angle 4 must be 133 by the supplementary angles theorem. Supplementary angles theorem, SAT. Angle 4 is 133 degrees. How about angle 5? We do know enough information to solve for angle 5 right now. There's many different ways you could do it. We could look at the transversal, but we don't really need to. Here's one thing we can notice. This angle 52 degrees plus angle 5 plus 47, if you take them all together, they would all have to add up to 180. So what we could do is we could add 52 and 47, see what we get there, and then subtract that from 180 to get angle 5. So 2 plus 7 is 9. 5 plus 4 is 9. So I've got 99 degrees. And if I subtract 99 from 180, we do that over here, run out of space. We'll take 180 and we'll subtract 99. Okay, we'll have to borrow all the way over, make this 17, make this 10. 9 from 10 is 1. 9 from 17 is 8. Okay, so the missing angle 5 is 81 degrees. And that would be, I guess, by the supplementary angle theorem. Okay, so angle 5 Supplementary angle theorem. Angle 5 is 81 degrees. Okay, angle 2. We have 2 of the 3 interior angles of this triangle shape right here. And so if we add up those 2 interior angles that we have and subtract from 180 by the triangle angle sum theorem, we'll be able to find the answer, TAST, for angle 2. And so I have to add up 47 and 81. 47 and 81. 7 plus 1 is 8, and 4 plus 8 is 12. So I got 128. If I subtract 128 from 180, I'll have it. So I'm going to run out of space here, I see. I'll do it here in this little area. 180 minus 128. Let's borrow from the 8, make it a 7, make the 0 a 10. 8 from 10 is 2, and 2 from 7 is 5. So this angle is 52 degrees. Angle 2 is 52 degrees by the triangle angle sum theorem. Angle 2 is 52 degrees. Now angle 1. Let's take a look at the other transversal here. I'll highlight it in green. This transversal right there. Now if you're looking for the Z shape, here it is. Okay, right here. See, I've outlined it in green. It's kind of a bent looking Z. All right. This is what you need to understand. This angle 1 right here is identical by the alternate interior angles theorem to this entire angle right here. Okay? So it's not angle 5, it's the sum of angle 5 and 47 degrees. So 81 degrees plus 47 degrees gives us this missing angle, 128. See, we already did the math right here, 81 plus 47. So angle 1 by the alternate interior angles theorem is 128 degrees. Okay, and if you didn't believe me on that, you could check by adding angle 1 to angle 2. They have to add to 180. So let's check that 128. Well, look, we did the math here. You see 180, 128, and 52. Angle 2's 52. Angle 1's 128, and they have to add up to 180, and they do. We show that by subtraction. So these are all correct. And number 6. Number 7, I will leave you to do, because it's just a series of things that we've already done. You now have enough information to do number 7, all on your own. But it just takes too much time in this video. Okay, number 8. We have to find the value of x. So here's where the algebra creeps back in. And I know that freaks people out, and people start losing their minds and saying, I don't know what to do. But just notice that you could have called these angles 1, 2, and 3, right? They just happen in this case to be algebraic expressions. But they still have to add up to 180 degrees by the triangle angle sum theorem, right? So that's all we're really doing. What you need to do is add them all together. So let me show you what that looks like. I'm going to have to write pretty small. So here I'll write 10x minus 11 plus 3x minus 2 plus 3x plus 1. And all of that mess there has to add up to 180. Okay, that's the key. So now let's combine like terms. I've got two 3x's there, they become 6x, and I have a 10x. So 6x plus 10x, or 10x plus 3x is 16x. And I've got here, let me write that. I've got 16x. And then I've got a negative 11 and a negative 2. Those add together, oh, and a positive 1. So let's do this. Negative 11 minus 2 is negative 13. Plus 1 is negative 12. So this is minus 12 equals 180. So let's just add 12 to both sides. Sorry, I'm being a little sloppy here. I'm trying to go fast. All right, so we'll have to add here. 0 plus 2 is 2, 8 plus 1 is 9, and 1. So 16x equals 192. We divide both sides by 16. Now, you won't have a calculator available to you, you know. So, you know, how do you divide this? Well, let's bring out a piece of scratch paper and let me show you exactly how to do 192 over 16. Okay, now this might be a refresher for some of you, and for some of you it might seem like a tedious bore, but we're going to have to prime factor 192, and we're going to have to prime factor 16. That's the only way we can do this, because if you don't know what 192 divided by 16 is, you're just going to be playing some game of trying to figure out what multiplies together to be, what multiplies by 16 to be 192, and there's a better way, there's a more clean way to do it. So let's just divide 192 by 2. Okay, so we'll do this 192 and then this weird looking division symbol here, upside down division. So 2 goes into 19 9 times with 1 remainder, and 2 goes into 12 6 times with no remainder. So 2 times 96 is 192, and we're just going to keep dividing by 2 like this. So 2 goes into 9 4 times with 1 remainder. 2 goes into 16 8 times. So we break it down again. 96 breaks down into 2 times 48. And from here we kind of can do it in our heads, right? Break it down again, 2 times 24. Break it down again, 2 times 12. Break it down again, 2 times 6. Break it down again, 2 times 3. So this is the full prime factorization of 192. All these numbers around the perimeter are prime. Let's do 16. 2 times 8, break it down. 2 times 4, break it down. 2 times 2. Now what we're going to do is rewrite this fraction as product of primes. Let me show you what I mean. This is cool. There's going to be a lot of cool cancellations in this. Draw a big fraction bar. And in the top, you're going to write all this. 1, 2, 3, 4, 5, 6 twos. 2, 2, 2, 2, 2, 2. 6 twos and 1, 3. They're all multiplied together. So this is called the product of the primes. And then in the denominator, we're going to write the prime factorization of 16. 2 times 2 times 2 times 2. And now we can cancel out every time we've got a pair of 2s. So here, 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 and here, here. So all that's left in the numerator is 2 times 2 times 3. Well, 2 times 2 is 4. 4 times 3 is 12. So 192 divided by 16 is 12. All without a calculator. So those 16s cancel and x equals 12. Now, you're not done, right? You're not done. And you need scratch paper to do this problem. You now know that x is 12. So what you have to do is you have to go in and evaluate each of these little algebraic expressions. Okay? Think about it like this. You have 10x minus 11. Okay? If you put this into f of x notation, you could write f of x equals 10x minus 11. So evaluate f of x, evaluate the function at x equals 12. All right? So this would equal 10 times 12 minus 11. Okay, so 10 times 12 is 120 minus 11. Okay, that'd be 109. Right, 120 minus 10 minus 1. Yep, 109. So this angle right here, angle 1, is 109 degrees. We just need to find one more, and then we can use the triangle angle sum theorem to find the other angle. Let's do this one. So I'll say f of 12 equals 3 times 12 plus 1. Okay, well 3 times 12 is 36, plus 1 is 37. See that? So now I know this angle 2 right here equals 37 degrees. Well, now I don't have to do the other one. I can. Let me show you. So f of 12 equals 3 times 12 minus 2. Okay, so that's 36 minus 2, which is 34. So this is 34 degrees. But let me show you how else you could have got it. You could have added 109 and 37 and subtracted from 180. 109 and 37. 9 plus 7 is 16, carry the 1. 3 plus 1 is 4. Bring down the 1. You got 146, subtract that from 180. Okay. Borrow from the 8, make this a 10. 6 from 10 is 4. 4 from 7 is 3. So you see it's 34 by the triangle angle sum theorem. So I wish they'd label these angles. I would say you should do it like this. The measure of angle 1 equals 109 degrees. The measure of angle 2 equals 37 degrees. And the measure of angle 3 equals 34 degrees. And you did all that by the triangle angle sum theorem. Okay, and I would put this in the box. I mean, label the triangle by all means, but this is the way I would present it. It's easier to grade. Make sure you're keeping your side work together. I'm not doing a very good job with the side work here. It's just kind of all over the place. Okay, let me show this on number 9, because number 9 is kind of weird. We're still going to be using the triangle angle sum theorem, but we're actually given this angle. That's 90 degrees. Right? That little symbol. So what we can say, you could look at this two ways. You know that all the interior angles have to add up to 180, right? So by this logic, if you add 7x plus 5 and 3x minus 5 and 90, it has to equal 180, right? So let me show that here. Triangle angle sum theorem. 7x plus 5. I'm sorry, I'm left-handed. Plus 3x minus 5 plus 90 has to equal 180. And a quick simplification would be to subtract 90 from both sides. And now you only have to add up to equal 90, like that. So let's see what we can combine here. These 5's cancel out, 5 and negative 5. And now I have 7x and 3x, that's 10x equals 90. This is easier than the other one, isn't it? Now we just divide both sides by 10. And you get x equals 9. So we can plug it in. We can probably do it on the paper here. 3 times 9 minus 5 will give me this angle. Well, 3 times 9 is 27 minus 5 is 22. So this angle right here is 22 degrees. And now I can do 7 times 9 plus 5. Well, 7 times 9 is 63 plus 5 is 68. Okay, so that's 68 degrees right here. I guess we won't label them. I don't know. I'm getting lazy. Here, I would just maybe circle them. There are your angles here. And you did the triangle angle sum theorem to get that. Okay, number 10, you have to apply the exterior angle theorem. Remember, the exterior angle theorem, EAT, says that 151 is equal to the sum of the two non-adjacent interior angles. So, what we can do is add these up and set them equal to 151. So that's what I'm going to write here, 11x minus 1 plus 20x minus 3 equals 151. And now you just have to simplify and solve for x. So let's do the common terms here with the x's. 11x plus 20x is 31x. And negative 1 and negative 3 is negative 4. And that equals 151. So now we're going to add 4 to both sides. And 151 plus 4 is 155. So 31x equals 155. And I can see right now that it's going to be 5. Because if you take 31, 31 times 5, and then it's 15. So you divide both sides by 31. Just kind of did it in my head. X equals 155. Well, sorry. Got cocky there. X equals 5. So now we can plug in and solve for the missing angles. All right, so maybe you can almost do it in your head at this point, guys. So 11, we're going to plug in x equals 5. So 11 times 5 is 55 minus 1 is 54. And 20 times 5 is 100 minus 3 is 97. Okay. Let's look at 11. What's going on with 11? Looks like I'm going to have to... Okay, so we can... This is by the exterior angle theorem, by the way. Same thing here. So we're going to set 14x minus 3 equal to the sum of these two things. Because this is the exterior angle, and these are the two non-adjacent interior angles. So 14x minus 13 is equal to the sum of these two angles. 4x plus 13 plus 6x plus 2. Okay, so combine like terms on the right. 4x and 6x are 10x, and 13 and 2 are 15. So I've got 10x plus 15. And we'll just bring all this down, 14x minus 13. And now we can just choose which side to solve for x on. Get it x on, like the gas company. We'll subtract 10x on both sides. And I get 4x minus 13 equals 15. Add 13 on both sides. And that adds up to 28. So 4x equals 28. So x equals 7. All right, and now let's just plug it in. Let's do the easy ones first. 4 times 7 is 28 plus 13. That would be 28, 38, 41. Okay, so this is 41. 6 times 7, here I'm doing this one. 6 times 7 is 42 plus 2 is 44. And these added together are 85, and that's what this should be. All right? I just want to do it to make sure that we're right. 14 times 7 is 98 minus 13. Let's make sure that that comes up to 85. It does. Okay, so this is 85. And these three angles were solved using the exterior angle theorem. It's not that bad, really. What else is in this thing? Find the values of x and y in the diagram below. Okay, so now we've got x and y. Ooh. All right. Well, we're given that this angle right here is 6x minus 11 by the vertical angle theorem. These opposite angles are equivalent. So this is also 6x minus 11. And now we can use the triangle angle sum theorem here, all right, to find out what this angle is, because we have everything on this side in terms of x. Over here, we can't mix these two yet because we have y and x. So let's solve for the triangle on the right using the triangle angle sum theorem. What does that mean? Well, it means that 6x minus 11 plus x plus 5 plus 81 have to add up to be 180. That's by the triangle angle sum theorem. Okay, all the interior angles of a triangle have to add up to 180. So let's combine like terms on the left. I've got 6x and x for 7x. And negative 11 and 5 gives me negative 6. Okay, plus 81. I guess I should have done that. Plus 81. Just made myself an extra step. Equals 180. All right, so now I have to combine these two. So 81 minus 6 is 75. So 7x plus 75 equals 180. And now I subtract 75 from both sides. Seven x equals 180 minus 75, which is 105. So let's divide both sides by 7, and let's hope that 7 goes into 105 evenly. Otherwise, we got ourselves a problem. Okay, it's going to, because 7 goes into 10 once with 3 as a remainder, and 7 goes into 35 5 times. So it goes in 15 times. X is 15. Well, now that we know x is 15, we can actually solve for this angle here and this angle here. Let's go ahead and solve for this angle here. 15 plus 5 is 20. So this angle is 20. And 6 times 15, what is that? Is that 90? I can't remember. So let's do 15 times 6. Yeah, it's 90. 15 times 6 is 90. So 6 times 15 is 90 minus 11 is 79. So this angle here is 79. And this angle here is 79 by the vertical angle theorem. Well, now that we know that, we can solve using the triangle angle sum theorem. We can do the same thing over here for y, because now we know that this is 79. I don't know if I'm going to run out of space or not. I probably shouldn't have written this here. Let me try to squeeze it in. To my one criticism of this packet, there's not enough space to do the work. All right, 4y minus 18 plus y plus 14 equals 70 plus 79 equals 180. That's the triangle angle sum theorem at work again. So let's combine like terms. I have 4y plus y is 5y. And let's see if we can knock this math out. Negative 18 plus 14 is negative 4. Negative 4 plus 79 is 75, right? So 5y plus 75 equals 180. Is that what I'm saying? And now I'll subtract 75 from both sides. And I have 5y equals 105. I know that 5 is going to go evenly into that. We can do it in our heads. 5 goes into 10 twice with no remainder, and 5 goes into 5 once. So it's 21 times 5. Y equals 21. Well, now that I know that y equals 21, I can just plug it in here. 21 plus 14, that's 21, 31, 35. So this is 35 degrees. And I can plug this in here. 4 times 21 is 84. 84 minus 18, is it 66? Let's see. 84, 74, 64, yeah, plus 2 is 66. Okay, so this is 66. Just double check that. 84 minus 18. Yep, 66. Okay, so this is 35, this is 66, 79, 79, 81, and 20. Solved all the angles. Number 13. Okay, so here you're given a bunch of writing, and it looks hard. And I don't like these problems any more than you do. So we just have some triangle MNP. And my advice, guys, is to draw a triangle, okay? I don't know what the angles are. I'm just going to make it up. It doesn't tell us anything about these angles. So just draw it, and don't worry about whether this makes any sense visually. So this angle here, M, we'll label these M and P. So angle M is 4x minus 3. Angle N is 9x minus 6. And angle P is 6x minus 1. So it wants us to find x in the measure of each angle. Well, remember, by the triangle angle sum theorem, all of these have to add up to 180. So let's just add 4, let me do it correctly here, 4x minus 3 plus 9x minus 6 plus 6x minus 1 equals 180. Combine like terms on the left. 4x, 9x, and 6x. 4x plus 9x is 13x plus 6x is 19x. 19x. And here I've got negative 3, negative 6. That's negative 9 minus 1 is negative 10. Let me make sure I did that right. 4x plus 9x is 13x plus 6x is 19x. Okay, it doesn't look right. Now we got negative 3, negative 6, and negative 1. So it's negative 3 minus 6 is negative 9, minus 1 is negative 10. Okay. So 19x minus 10 equals 180. Now we'll add 10. Oh, I see. Now we'll add 10 to both sides. This is cool. So 19x equals 190. Divide both sides by 19, okay, and x equals 10. So now that we know x equals 10, we can find all the other angles. So 4 times 10 is 40 minus 3 is 37. 9 times 10 is 90 minus 6 is 84. And 6 times 10 is 60 minus 1 is 59. And let's check it to make sure we did it right. Let's just add all these up, and let's make sure that they add up to 180. So 37, 84, and 59. They should add up to 180. 7 plus 4 is 11 plus 9 is 20. carry the 2. 2 plus 3 is 5, plus 8 is 13, plus 5 is 18, 180. How about that? So now we know that angle M is 37 degrees. We know that angle N is 84 degrees. And we know that angle P is 59 degrees. Okay, number 14, that's number 13 done for you. Number 14 coming up. In triangle RST, all right, before we get into all that nonsense, we're going to draw a triangle just to get a visual going. Okay, so this is triangle RST. The measure of angle R is 5 more than twice 6, so 2x plus 5, or sorry, 2x plus 5, yep, twice x is what I meant to say. So angle R is 2x plus 5. This is angle S here. 1 more than x, so that's x plus 1. And t is 16 less than 7 times x, so 7x minus 16. We're doing the same thing again, guys. We're just going to add all these up and subtract from 180. Okay. I thought, I'll show you something like another way to do this. You can stack add these. 2x plus 5, x plus 1, and 7x minus 16. Okay, they can be added, and I don't know if you'll find this easier or harder, but you kind of add them. You kind of add them like they're two separate things. So 2x plus x is 3x plus 7x is 10x, and then 5 plus 1 is 6 minus 16. 6 minus 16 is negative 10. So that's 10x minus 10. Okay, and all that has to equal 180. All right, so you add 10 to both sides. And now you have 10x equals 190. Divide both sides by 10, so x would equal 19. Okay, and if that was confusing to you, show it another way. You would just do 2x plus 5 plus x plus 1 plus 7x minus 16 equals 180. All right, so this is the way we were doing it before. You're just doing the same thing, 2x plus x plus 7x. 2x plus x is 3x plus 7x is 10x. 5 plus 1 is 6 minus 16 is negative 10. So you're just back to where you were before. It's your preference whether you like the stack adding method or not. It can be confusing. So now we know that x is 19. That's going to make the math harder. Okay, so 2 times 19 is 38. Plus 5 is 43. So this is 43. 19 plus 1 is 20. 7 times 19 minus 16. Well, I actually don't know that one, right? What's 7 times 19? You know what we could do is just add 43 and 20 and subtract from 180. So 43 plus 20 is 63. And let's do 180 minus 63. And then we'll check our work. So 7 and 10. So 7, 1, 1. 117. Okay, so let's check that. Let's see if 19 times 7 minus 16 is 117. Okay, so this is 63, carry the 6. Oops, I don't know why I wrote a 3. And then it's 13, 136 minus 16. Okay. Oh no, that's not going to work. Oh, I don't know why I got it all backwards. I must be getting tired. It is 9:52 p.m. So 9 times 7 is 63, and I wrote a 6. I just did it again. 9 times 7 is 63. Carry the 6. 1 times 7 is 7 plus 6 is 13. So now I have to subtract 16 from 133. Okay, so now I'm going to borrow the 2 and make this 13. And here we go. So 13 minus 6 is 7. 2 minus 1 is 1, and 1. So yeah, it checks out. This is 117. So this is 43, this is 20, and this is 117. So R is 43. I suppose we should check it, right? Well, we kind of did. 43 plus 20 plus 117 does add up to 180. S is 20, and T is 117. Okay? I think you can do numbers 15 and 16 on your own, because this is 51 minutes long already. So really, if you've watched this video, you have to do all by yourself number 7, number 15, and number 16. You should be able to do that, guys. Listen, I put myself out there tonight doing this. I've recorded like 2.5 hours of videos tonight just for geometry. If you found this helpful, if this benefited you, if you think this will help your grade and help your understanding, please consider giving the video a like and leaving a comment. The comments are what's going to propel the video in the search rank. So I would love for you to leave comments and like this video. And if you haven't already, if you're a student in this school, even if I'm not your teacher, but you're watching this video, please consider subscribing and hitting that little notification bell so you're always alerted to when I release new videos, because not all of you are on the Remind group, so you're not getting these messages. All right, guys, thank you very much. Have a great day.